So now let's look at some examples of preferences. So the first one we're going to look at is perfect substitutes. Substitutes. So here's the consumer. For these kind of preferences, perfect substitutes, the consumer is willing to sub or substitute one good for the other at a constant rate. So, the simplest version of this would be, on a example, a 1-to-1 ratio, or rate. So, they're willing to substitute one of good 1 for one of good 2, and they're kind of indifferent towards these two goods. So, for example, let's imagine there's two goods. Black and blue pens. Maybe I should have done orange and blue pens, I guess. So black and blue pens. And you don't care about the color. You don't care if you're going to write your Econ 212 notes in black or blue. You're indifferent towards them. So what we can do here now is pick a bundle. We're going to think about how to draw these indifference curves for this situation. So let's pick a bundle. So let's say the bundle is 5 of each kind of pen, 5 black pens and 5 blue pens. Now any bundle with 10 pens total is just as good as the bundle 5-5. Because really you don't care if you have black or blue pens, what you care about is the number of pens total you have. So as long as x1 plus x2 equals 10, we're indifferent towards how much of good 1 and how much of good 2 we have, as long as we have a total of 10. We're indifferent towards this bundle 5-5. Right, so if we wanted to draw this, so let's say these are our blue pens, and these are black pens, and let's say this is 5 and 5, wherever this is our bundle. As long as it adds up to 10, we don't care. We're indifferent towards any bundle. We'd be happy if we had, my slopes are pretty bad here. Let's go. This is 5-5. We could have 10 blue pens and 0 black pens, and we're just as happy as 5 of each. Or we could have 10 black pens and 0 blue pens, and we're just as happy as 5 of each. So we have these straight line indifference curves when we have perfect substitutes. So notice this is like the really simple case where the slope is 1, because they're willing to exchange them on a 1-to-1 ratio. But it's, you could have it so, you're indifferent between 2 nickels and 1 dime, and that's, the slope is not going to be 1 anymore, right? I mean, it depends which axes you have nickels and which ones you have dimes on. But it's not going to be a 1-to-1 ratio. You're indifferent between 2 nickels and 1 dime. Again, that's kind of the assumption that you don't care the volume of change you have in your pocket. So keep in mind that the slope doesn't have to be 1, or in this case, -1. I should be careful here, but the key is they have a constant slope. So the key is a constant slope. Doesn't have to be a 1-to-1 ratio. It could be like a 10-to-1 ratio. But the key is like these perfect substitutes have some constant slope. So the second example of preferences that we're going to look at are perfect complements. So the first was perfect substitutes. Now we're going to look at perfect complements. And this is for the situation where the consumer likes to consume the goods in kind of fixed proportions. The consumer consumes, the individual consumes the goods together in fixed proportions. For example, it could be like printers and printer ink is like a classic. Ink, some proportion where you consume those together. Another classic example, assuming that you're going to use both shoes, would be like left shoes and right shoes. Assuming that you need both shoes. So, for example, imagine a consumer. So let's kind of explore this left and right shoes, and let's again kind of draw out what these preferences might look like. Imagine a consumer likes shoes. But always wears a right shoe and a left shoe together. So we're making that assumption that they want to wear both kinds of, both a left shoe and a right shoe, the same kind of type of shoe, I guess, too. So we're making this assumption that having one shoe out of a pair does the consumer no good. So let's think about what these preferences look like in terms of indifference curves. So let's put left shoes as good 2 on the y-axis and right shoes as good 1. Well, let's start off with one of each shoe. Well, if having a little bit, having more right shoes does the consumer no good unless they have more left shoes as well. So the consumer is kind of indifferent between this 1, 1 with adding any number more of right shoes. They could have 2 right shoes and 1 left shoe, and they're just as happy as if they had 1 of each, because they need both shoes. All the way up to like 10 or infinity, really, right? They're different between 1 left shoe and an infinite amount of right shoes and 1 of each shoe. And we can say the same in terms of left shoes. If they had 2 left shoes and 1 right shoe, they're just as happy as if they had 1 of each shoe. So our perfect complements have these kind of like right angle indifference curves. And in this case, there'd be, here's 2, and let's put 2 up here. Then we have another indifference curve here at 2, 2, and they're indifferent between having 2 of each shoe or having 10 right shoes and 2 left shoes. So we have these right angle indifference curves.